Hi everyone. So before starting the solution, I will share a very funny incident with you. So I was done with the whole recording of this complete test series. Okay, I solved all the problems. I was done with the recording. Then when I was compiling all the videos, when I was putting the timestamp, at that time I realized that the sound did not come. Okay, so the whole recording I have to do it again. I have to record right from the beginning again. So I was feeling really bad a few hours ago that I did all the efforts. Now I have to put all the efforts again. So for that you can put a like. It will make me feel good. That's it. This is what I wanted to ask, because putting the same effort again, it feels a bit more frustrating. So you can put a like. If you get 150 likes on this video, it will make me feel good. That's it. This is just a ask I wanted to make. Nothing else. Okay. So yeah. Now, first, now talking about our test series. So we have launched our test series on our PrepFusion platform. You can go to prepfusion.in. You can go to that our website. There you can see we have launched our complete test series for analog VLSI mastery cohort 0 to 100. So AIMT 1 and AIMT 2 you must have attempted. Now we have launched the complete test series. There are 16 topic wise tests, 4 full length tests, and all the problems are placement oriented. You must have seen the level of AIMT 1 and AIMT 2, the kind of problems we are asking. These kind of problems only you will see. All will be placement oriented. It's not that we will be asking a lot of tough problem or a lot of easy problem. In between, the problems level will be there. Easy problems also you will see, tough problems also you will see, moderate level problems also you will see. So with that you will be able to attempt your online test for your companies very well. Okay, so you will be very much comfortable with the online test, with the written test of the upcoming placement season. So there will be total 320 plus problems. So that would be more than enough. Like, people always look for practice resources. So this practice resource would be more than enough for you. Okay, so this practice resource will be pretty good. So total 320 problems, and video solution will also be there. Currently I am working on the video solution. So for first 5 to 6 tests you will see the video solution, but for the OPAM video, for the OPAM test series and for MOSFET test series, I am currently working on the video solution. I will soon upload it. In 2 to 3 days, I will completely upload the video solution. Okay, and then test result analysis also you will see in the same manner that you have seen in AIMT 1 and 2. Okay, so this is the test series which you can purchase. Now I will talk more about the test series. So these are the topic wise tests. So basic of network and theorems, there will be 3 tests. RCRL, RLC circuits, there will be 3 tests. Diode circuit, there will be 2. MOSFETs 3, OPAMs 3, BJTs 2, and then one full length test for cohort 0 to 10, one full length test for 11 to 100, and then there will be 2 AIMTs. So these tests will be there. Total 320 problems will be there. Okay, and now you can apply the code India 78. So the actual price is 779 rupees, but if you apply the code India 78, then you will get it in 499 rupees. Okay, so 320 plus problems you are getting, high level problems, a good level of problems you will get in just 499 rupees, and this is applicable till 15th of August only. Till 15th of August you can apply this code. Okay, so India 78 code you need to apply. Now those guys who are already having these courses, these are our placement courses. In these courses you will get everything. So these guys do not need to purchase this test series. Okay, so in these courses you are already getting complete video lectures, you are also getting aptitude, you are also getting aptitude test series, you are getting technical test series as well, you are getting doubt solving as well, live doubt solving group as well. All the video content is also there. So everything that is required for the what kind of project you need to do, what kind of things you need to put in the CV, all this guidance also I am giving here. So if you are enrolled in this course, you don't need to purchase that particular test series. And if you aren't enrolled in this course, then you can enroll in this course with the code India 78. So this is valid till 15th of August only, India 78. So if you apply this code, this price will go down drastically. This will go down to 2700, and this will go down to roughly around 3800. So this much off is there, and in 2700 you are getting so much of thing. We complete video content, doubt solving group, live doubt solving session. Personally, I will be clearing all the doubts. Also, you will be getting test series for aptitude as well. You will be getting test series for what you need to put in the CV, what kind of projects you need to do. Every single thing that is required for getting into, for preparing for placements, for analog VLSI placement, that is there. So you can consider purchasing this course. You can consider buying this course. So that's it about our courses. This is the test series. So in brief, I have already launched the test series. So you can go to our website prepfusion.in, or I will put the link in the description as well. There you will find this particular test series and you can make your purchase. Okay, then let's start with the solution. So in this problem, what you need to find? You need to find output voltage, but the op-amp is not ideal. Okay, op-amp is having a finite gain of 10 to the power 3 and Vin is 2 volt. So what will be your V naught? This is what they are asking. So what you need to find? First you need to find this potential, because since op-amp is not ideal, then this node will not be 0. Virtual short will not be valid here. So first we need to find this potential. How will you find this potential? V in into 100 plus V naught into 100 divided by 100 plus 100. V1 into R1 plus V2 into R2 divided by R1 plus R2. I hope you know this thing. So 2 into 100, 200 plus, 2 into 100 plus V naught into 100 divided by 200. So what you will get? 2 plus V naught divided by 2 into 100, 2 into 100 plus 100 into V naught divided by 200. Right? So 1 plus V naught by 2 you are getting. 1 plus V naught by 2. 1 plus V naught by 2. So 1 plus V naught by 2 into 10 to the power 3, and then minus sign will also be there, is equals to V naught. Right? So 10 to the power 3 plus 10 to the power 3 by 2, that would be 500 V naught, is equals to minus V naught. So V naught would be equals to, this would be 501, this would be minus 501 V naught divided by, is equals to 1000. So V naught would be equals to minus 1.996 volt. That's it. So this is how you need to solve it. It is nearly around 2. All the options are nearly around 2 only, but it would be lesser than 2. So answer would be first one. Okay then. Let's see the solution of this one. Op-amp is ideal. What you need to do? You need to find input and output impedance. Since op-amp is ideal, virtual short is valid. From here you need to see the input impedance. What that would be? If you need to see the input impedance, what you will do? You will apply V in and get I in out of it. So what will be the value of I in? I in will be V in by 12k. That is equals to I in. So V in by I in, that is equals to your R in, that is equals to 12k. So first answer is 12k. Now what you need to find? You need to find output impedance. So for output impedance, what you need to do? For output impedance, you need to nullify the independent sources. What is the independent source? That is our V in only. So if I nullify this, this node will be 0. This is 0, this is 0. That means there will be 0 ampere current from here. If 0 ampere current from here, this will also take 0 ampere current, then 0 ampere current will be flowing from here as well. Then what will be your V naught? This 0 will travel down here, V naught will be 0. So R naught you would be finding from here, right? R naught will be V naught by I naught, where your V naught is 0, 0 by I naught. So R naught is 0. So 12 kilo ohm and 0 kilo ohm. Understood this concept? Input impedance 12 kilo ohm. Very easy. From here you need to find input impedance. That is 12 kilo. Output impedance, V in will be shorted. So 0, 0, 0 ampere current is flowing here. So V naught is 0 only. So R naught is 0. Okay then. Let's see this one. Here you need to find the differential gain. Okay. Differential gain. And input voltage is given, that is 5 volt. So what would be this potential? Let's just say this potential is Vx. So that Vx potential will be 5 into 1 kilo ohm divided by 501 kilo ohm into AD. That would be equals to 2.5. So AD would be equals to 2.5 into 501 by 5. So that would be equals to 250.5. That's it. This is your AD. 250.5. That's it. That's your answer. Okay. Very easy. You just need to find the differential. Here also you need to find the gain only. So people will be solving it, but some people will take time. Some people will solve it quickly. So what would be this potential? Tell me. V in by 2, right? Because if you apply nodal here, x minus 0 by 2r plus x minus V in by 2r. Or directly you can see it will be potentially divided because both will have the same current. Input of op-amp will drive 0 ampere current. So both will have the same current, right? So directly you can write here, this would be V in by 2. Now if this is V in by 2, this will also be V in by 2. Say yes or no. Let's just remove it. This will also be V in by 2. Now if this is V in by 2, what this potential will be? You can again apply nodal. V in by 2 minus 0 by r plus V in by 2 minus x by r. So x value will come V in. Or you can see this is acting as a non-inverting amplifier. It is non-inverting amplifier only. So this will be V in. Now you have reached till this point. You have reached till this point. This is your V in. And what is this current? This current is V in by 2R. V in by 2R. And the same current V in by 2R would be flowing here. V in by 2R. And what is this current? This current would be V in by R. Right? This is V in minus V in by 2, V in by 2R current. This is V in by R because this is V in and this is R. So V in by 2R, V in by R. So what would be the total current here? V in by R plus V in by 2R, 3 V in by R, 3 V in by R, right? Are you getting this point? 3 V in by 2R, sorry, because half V in by R plus V in by R, so 3 by 2 V in by R, so 3 by 2 V in by R. Now can you write down the potential of V naught? Can you write it down? Yeah, certainly I can write down. How will I write down? V in plus 3 V in by 2R into R is equals to V naught. So 2.5 V in is equals to V naught. That's it. This is the answer. Got it? V in, this is V in by 2, V in by 2 here, V in by 2R here. If this is V in by 2R, this is V in. This is driving V in by R current, this is driving V in by 2R current. So this will be driving 3 V in by 2R current. So what would be the drop here? 3 V in by 2. So V in plus 3 V in by 2. That means V in plus 1.5 V in. That would be 2.5 V in. This is the answer. Okay. Well, let's see the solution of this one. Here you need to find the output voltage. Again you need to find the output voltage. Here V in 1 expression is a little bit complex. So I will put V in 1 as V in 1 only. So if this is 0, this is 0, this will also be 0. What would be this potential? This potential will be minus 10 V in, minus 10 V in 1, right? Now you need to find V naught. If this node is 0, this node is also 0. So you can apply nodal at this 0 potential. Okay. People will apply superposition theorem as well, but nodal is very easy here. No, I will simply apply nodal. So 0 minus 10 V in, that means 10 V in 1 divided by 1 kilo ohm plus or minus V in 2 divided by 1 kilo ohm is equals to V naught by 20 kilo ohm, right? So what you get? 200 V in 1 minus 20 V in 2 is equals to V naught. So 200 V in 1, 200 V in 1. That means I can put it as 0.2 into 10 to the power 3 into V in 1, and similar thing I can do here, because what is V in 2? V in 2 is minus 10 millivolt. So this would be 200 millivolt. 200 millivolt. Okay. So 200 millivolt into V in, 200 millivolt into V in 1. So that would be this is 200 volt and this is millivolt. So it would be simply 0.2. 0.2 plus 0.4 sine omega t plus 0.2 is equals to V naught. So V naught would be equals to 0.4 common 1 plus sine omega t. This is the answer. That's it. 0.1 into 1 plus sine omega t. So calculation you need to take care. Okay, millivolt is there, 10 to the power minus 3 is there, and here you are having 10 to the power plus 3. So 0.2 only you are getting. So 0.2 into 0.2 plus 0.4 sine omega t plus 0.2. So this is what you are getting. Okay, just a calculation was the main issue. In this problem you need to find CMRR. So how do you define CMRR? CMRR is differential gain upon common mode gain, right? But this is in decimal, not in dB. If you define it in dB, then how it will be? Differential gain in dB minus common mode gain in dB. Because if you want a decimal to dB, then what you will do? You will take log 20 log 10. So if you take 20 log 10, that means log A by B, log A minus log B. So it would be subtracted, not divided. So 48 by 2, 24 is wrong. Okay, it would be 48 minus 2, 46 dB. So answer is 46 dB. Okay, so sometimes people can mess it up here, that they will do 46 by 2, but that is in decimal. If you are calculating in dB, then you have to subtract. Let's see the solution of this one. So is there any hysteresis? What do you mean by hysteresis? This is what we mean by hysteresis. In Smith trigger we get hysteresis, but it is not Smith trigger because there is no hysteresis. So certainly these two options are wrong. Now it is a comparator, right? What comparator does? What comparator does? Now the thing is, if it is inverting comparator or non-inverting comparator, that you need to find out. So how will you find out? What a comparator does? If a particular value is greater than that particular value, then it will give you plus V set, otherwise it will give you minus V set. Now the thing is, let's just say this potential is x. So this potential I can take as x. Now if my V in is greater than x, then I will get plus V set, right? And if my V in is less than x, then I will get minus V set. So what kind of comparator it is? Non-inverting comparator, right? Non-inverting. Because for greater value, you are getting higher value only. For greater value, you are getting higher value only. Inverter. We call it inverting. Why do we call it inverter? Because if I apply low, I will get high. And if I apply high, I will get low. In Smith trigger, I told you this concept. I taught about this concept very, very deeply. If your input is connected at the non-inverting terminal, that means it will be non-inverting Smith trigger. And if your input is connected at inverting terminal, that means it would be inverting Smith trigger. Then we draw the hysteresis curve. Here there is no hysteresis. This is simple comparator. That means if Vin is greater than X, then I am getting plus V set. And if Vin is less than X, I am getting minus V set. That means my input is connected at non-inverting terminal. If my input was connected here, then the response will be something like this. Response would have been something like this. So this would have been inverting. But this is non-inverting. Okay. So by the concept of inverter also you can understand the inverter will give you if high value then low and low value then high. But here if high value is there, you are getting high value only. So this is non-inverting comparator. Okay. Let's see the solution of this one. So in BJT there will be Zener diode connected. If question is coming from BJT, there is high chances that they will give Zener diode with that. Okay. So VB on is 0.7 volt and this is 10 volt battery. So there is very high chance because there is 30 volt connector. So there is very high chance that it will go into breakdown. So Zener is going into breakdown. This is what we are considering. So here you will get 10.7 volt. How will you check? We will check if the current is flowing from N to P. If current is flowing from N to P, that means it is certainly going into breakdown. So 0.7 and then 10. This is 10.7. So how much current is there? 30 minus 10.7, 19.3 divided by 100. So I can say 193 milliampere. Say yes or no. 193 milliampere. Okay. Our target is to find I. If this current is I, tell me what this current would be. I by beta. Because this is collector current. What would be the base current? I by beta. The same current will be flowing here. So I by beta current. This is I by beta current. Now what about this current? This is 0.7. This is 10. This is 10.7. This node is 10.7. So how much current this is driving? 107 milliampere, right? 107 milliampere current I by beta. So what I can write? I can write 193 is equals to I plus I by beta plus 107. From there I can get the value of I. So value of beta is 5. Value of beta is 5. So value of beta is 5. So it would be 6I by 5. 107 6 8 186. So I value I will get is not 186, only 86, sorry. 86 into 5 by 6. 86 into 5 by 6. So 71.67 milliampere. Okay. So that would be the answer of I. 71.67 milliampere. Let's see this one. You have to find the sign of A and B for negative feedback. So if I start from here to here, how much phase shift is there? 180 degree. Because if this node increases, then this node is connected to non-inverting terminal. So if this node increases, then this node will decrease. Or you can say this is an inverting amplifier. Simply it is an inverting amplifier. So it is converted to inverting terminal. So this node will decrease. So basically there is 180 degree phase shift. You want negative feedback. That means you need 0 degree phase shift from here. 0 degree phase shift from here. So if this node is decreasing, that means this node is certainly decreasing. Same node is there. So you want 0 degree phase shift there. That means you need A to be positive and B to be negative, right? A has to be positive because if this is decreasing, then this will decrease, right? Because you want if you are increasing your output, you want eventually you want your output to decrease. This is what negative feedback means. Negative feedback doesn't mean that A is positive and B is negative. It doesn't mean like that. Okay. Just if this is going down, then other nodes should go down only. So A has to be positive and B has to be negative, right? Why is that so? Because 180 degree phase shift you are already getting from here. You need 0 degree phase shift from here. So this is the answer. Okay then. So in this question you need to find the value of Vx. So will that be 4 volt? 0 volt will come here. It will be 4 volt. No, that will be wrong. Why that would be wrong? Because let's just say if I say this becomes 0 volt. So what will be your V0? What will be your V0? V0 is 18 by 6 into 6 minus sign. So V0 would be minus 18 volt, which is not possible. So output is saturated. If output is saturated, that means virtual short is not valid. If output is saturated at minus 15 volt, that means virtual short is not valid. So this node will not go to 0, but they are not asking this value, they are asking this value, Vx value they are asking. So what we can do? This is how our circuit will look like. Vx 18, this is your minus 15, output is saturated, this is your 18, this is 4 ohm, this is 2 ohm, this is 6 volt, and they are asking the value of Vx because output is already saturated. So what will be the value of Vx? Can you find out? Vx will be 6 into 18 plus 4, that means 6 into 22 minus 15 into 2 divided by 22 plus 2, 24. So that would come out to be 4.25 volt. Basically V1 into R1 plus V2 into R2 divided by R1 plus R2, or you can apply nodal analysis as well, because this current, if this current is I, this current will also be I. Input of op-amp will not drive any current. Input of op-amp will not drive any current. So both current are same. Here also there is I current. So simply you can apply V1 into R1 plus V2 into R2 divided by R1 plus R2. So 6 into 22 minus 15 into 2 divided by 24, 4.25 volt. Right? So this is the option. Okay, 4 volt is wrong. Let's see the solution of this one. Q1 and Q2 both are matched. You need to find the potential V0. Here both of the MOSFET are in saturation region. Both are matched. That means both have same mu and Cux W by L value. Vt value is also same. Everything is same. Both are in saturation region. Both are driving the same current, right? Both are driving the same current. In the whole MOS, the same current is flowing. So if both are driving the same current, mu and Cux W by L value is same, Vt value is same. That means VGS of both of them will also be same. VGS of Q1 should be equals to VGS of Q2, right? Both of them will have the same VGS. So 5 minus 10I, this is the gate potential, minus V0. This is the VGS of Q1, would be equals to VGS of Q2, V0 minus 10I, right? So 10I getting cancelled. So V0 will be equals to 2.5 volt. So that's it. This is the answer. Okay, very easy. 5 minus 10I minus V0 is equals to V0 minus 10I. Okay, very easy. Let's see the solution of this one. Here what you need to find, VB is the DC bias, you need to find the small signal voltage gain. So VB is the DC bias, this will be shorted. Even this will also be shorted. VDD is also a DC bias. So basically from V0 to ground, what do you see? If I draw the model, this is your V in, this is ground, and this was your V0. So from V0 to ground you see 1 by Gm. From V0 to ground you see 1 by Gm. Parallel you see R0, and another R0 also you see, upward side. Another R0 also you see, right? So basically here you see 1 by Gm parallel with R0 by 2, right? So what would be the parallel combination of this? 1 by Gm into R0 by 2 upon 1 by Gm plus R0 by 2. So R0 upon 2 plus Gm R0. Say yes or no? So that would be R0 by 6, because Gm R0 value is 4. So that would be R0 by 6. So this particular combination is R0 by 6. So from here if I write down the gain V0 by V in, that would be GMRD upon 1 plus GMRS. Basically GMRS upon 1 plus GMRS. This is a common drain amplifier. We remember the gain, or if you don't remember you can derive it as well. From here you see 1 by Gm and this resistance you see. So basically R0 by 6 upon 1 by Gm plus R0 by 6, or directly we remember it as well. So it would be GM R0 is 4 divided by 6 plus 4, 10. So answer would be 0.4 volt per volt. That's it. This is the answer, which is option 1. Pretty good question it was. I wouldn't say very easy, but it was good question. Those who have good idea of a MOSFET amplifier, they would be able to solve it. In this question, you need to tell the output impedance from V0 node. Okay, from here you need to tell the output impedance. There is very interesting thing, that is R03 is infinity, and here VDD is the DC bias that we know. So VSG is also gone. VSG is gone. That means current source is gone. Small signal current is 0. R0 is also 0. That means M3 will be replaced with open circuit. This much idea you should have, right? And I am replacing M2 as it is. Let's just say I am replacing M2 as it is, and this is your V0. and then there is M1 as well. So from V0 to ground, what do you see? 1 by Gm. From V0 to ground you see 1 by Gm, and from V0 to another ground you see R0. 1 by Gm parallel with R0 you see. From V0 to ground you see 1 by Gm parallel with R0. Here you see M2 as well. Tell me one thing, if I say from V0, I need to calculate I0, right? If I say from here I0 current is going, I need to calculate R0, so R0 will be V0 by I0, right? From V0, if I say I0 current is going, then tell me one thing, where will the I0 current go? Complete I0 current will go here only. Why is that so? Because upper node is open-ended. No matter what network you are having, if you are not having the ground with you, in between it is open circuited, no? So there is no current here, no current can flow, right? So no current will go upward side, all the current will go downward side only. So our equivalent resistance is 1 by Gm parallel with R0 only, and 1 by Gm 1 by Gm1 parallel with R01. So your R0 will simply be 1 by Gm1, that would be 1 kilo ohm, parallel with R01, that is 3 kilo ohm. So 3 kilo ohm parallel with 1 kilo ohm, 3 by 4 kilo ohm. So answer would be B. So it was a good question. Okay. So only the downward will be counted, upward will not be counted. So if you keep on solving the problem, it will take a lot of time, but intelligently we got to know that only downward will be counted. Let's see this problem on diode circuit. So how do we solve the problems of diode circuit? By applying the open circuit test. So if I apply the open circuit test, then what will happen? This will be also open circuited. So 6 volt will come here, 3 volt will come here, this 3 volt will be here, and this will be 6 volt. That means this diode will turn on, this diode will be on, and 6 and 3. At N side you are having 6, at P side you are having 3. That means this will be off. So this is off and this is on, right? And if this is on, this will be replaced with the battery of 0.7 volt. So if it is replaced with the battery of 0.7 volt, then what will be your V2? You should have an idea of a diode circuit, then only you will be able to solve it. Otherwise you will say, sir, what you are doing? This is the method. First you apply open circuit test, then you got to know the operating condition. We got to know that diode D1 is, this particular diode is on. So if this is on, I can replace this with the battery of 0.7 volt because cut-in voltage is 0.7 volt. So how much voltage will come here? That is 5.3. So V2 is 5.3 volt. What about V1? Since this diode is off only, I will replace it with open circuit. This diode is off, so this will be replaced with open circuit only. So that means this will drive 0 ampere current, and if this is driving 0 ampere current, that means V1 will be equals to 6 volt, and then V2 is 5.3 volt. That's it. This is the answer. Very straightforward problem of diode circuit, but if you have the good idea, then only you will be able to solve it. Okay, then this is also a very straightforward problem on diode circuit. If you have studied diode circuit, you will be able to solve it. So diode have the cut-in voltage of 1 volt. You need to find the current I. So cut-in voltage of 1 volt they are having. So again I can apply open circuit test. If I apply open circuit test, then 0 volt will come here. Open circuit test I am applying. This is open circuit, this is also open circuit. So no current through this resistance. So 0 volt will travel here. So 5 and 0, this diode will be on. And if this diode is on, that means it will be replaced with the battery of 1 volt. And if it is replaced with the battery of 1 volt, this will be 4 volt. So here 4 volt, and from downward, if I apply open circuit test, again if I apply open circuit test, so this will be 0. So this will be replaced with, this will also be on, D2 will also be on. Basically, I will consider D1 and D2 both to be open circuited. Then I see what is the potential across D1, that is 4 volt, that means D1 will be on. What is the potential across D2, that is 0 volt. So we will hold on to D2. First we will turn on D1. So if I have turned on D1, then I got to know that here there is 4 volt. Now again I will apply open circuit test for D2 only. Then if I apply open circuit test for D2 only, then there will be 0 current here. So this will take up 0 volt here. If this is taking up 0 volt here, 4 and 0, this will also turn on. So both diodes will turn on. So this will give the voltage drop of 1 volt, and this will also give the voltage drop of 1 volt. So 5 minus 1, 4, 4 minus 1, 3. So here we will have it 3 volt. So 3 by 1.5, basically this will be 2 milliampere current. Now let's just say this is the network. Here I am having 2 milliampere current, and this is current, this is my I current. So what is happening? I current will be divided into these two, I1, I2, right? Then I1, I2 will be added and will become 2 milliampere again. I current is coming, divided into I1 and I2, and both are added, and again 2 milliampere current is being added. So basically I is equals to 2 milliampere only, no? Are you getting this point? So this 2 milliampere current is the same as 2 milliampere current. From upward side 2 milliampere current is coming, that is being divided into these two paths, then again 2 milliampere. That's it. This is 1 volt. So this complete 1 volt is exposed to this 1 kilo ohm resistance. So this will drive 1 milliampere current. So they could have asked you the current through D2 as well. So 2 milliampere here, 1 milliampere here. So this would be 1 milliampere. So from D1 2 milliampere current is flowing, from D2 1 milliampere current is flowing, and here 1 milliampere there, and here 2 milliampere is there. So what they are asking 2 milliampere. I value they are asking, that is 2 milliampere. They could have asked the current through D2 as well. So this is how you would have determined it. Okay, well and good. So let's see the solution of this one. So this is a very good question actually. So like it will take me 10 minutes to explain it here, but there will be a lot of concepts which you might not know. Okay, if you haven't studied the subject deeply, then there might be some concept which you might not be knowing, like impulse current. If the voltage across the capacitor is instantaneously changing, then how much current it will drive. So these kind of concept you might not know. So for that, this is the video. You can go check out peak director and average current through diode, analog electronics, PrepFusion, Himanshu Agarwal. You can check out here. In 1 hour, I explained it. Other problems also I have explained here. So here you will get much deeper idea. Here in the solution video, I cannot spend 1 hour, right? So here I will be going a bit faster. But those have the basic idea of average current and all those things, then they will be able to understand it. So if first see this solution, if you are not able to understand, then go here. Okay, because this is a very deep concept and it is a very good question. Not everyone will be able to solve it. Okay, like 1% people only will be able to solve it, not even 1%. So let's check out this. So this is your V in waveform. You need to find out the diode current, average diode current. So what will be your diode current equals to? Capacitor current plus resistor current. This you would know, right? Diode current is equals to the capacitor current plus the resistor current. Now initially what will happen? 10 volt will come directly. 10 volt will come. Capacitor is having 0 voltage. Diode will turn on. So at t equals to 0 plus. At t equals to 0 plus. From t equals to 0 plus, diode will turn on. Capacitor will charge to 10 volt directly, right? Capacitor will charge to 10 volt. Tell me what will be the capacitor current. Can you tell me? What is capacitor current? Capacitor current is C dVc by dt. C into change in the capacitor voltage. Initially it was 0, suddenly it is becoming 10 volt. So change is 10 volt. In how much time? In 0 time. So that would be tan C delta t. Are you getting this point? The current would be tan C delta t. Did you understand this point? C dVc by dt. Time is 0. That means impulsive change is there. And how much voltage change is there? 10. So current would be tan C delta t. And what would be the resistor current? Because 10 volt is there across the capacitor and the same voltage is there across the resistor as well. So what would be the resistor current? That would be 10 by R. So if I draw the waveform, what do I see? A capacitor current is there, that is tan C delta t. It just came, that's it. After that it is not there. Now till t by 2 time, this would be 10 by R, because till t by 2 time 10 volt will be there. This is our resistor current, that is 10 by R. This I am drawing diode current, okay, diode current. But this is not the steady state. We will check the steady state now. After that what will happen? This is diode current I am drawing. Are you getting this point? 10 by R, 10 C delta t. Addition of both of them is the diode current. Till this point it is crystal clear, right? Now your capacitor has been charged to 10 volt. Capacitor has been charged to 10 volt. And then here there is resistor connected. Now at t equals to t by 2 plus, what is your input? Input is 0 volt, right? At t equals to t by 2 plus, input is 0 volt. Here you are having 10 volt, here you are having 0. Diode will be off, right? Diode off. That means your diode current will be 0. Diode current will be 0 ampere, right? Diode current will be 0 ampere from t by 2 to t. But what will happen to this capacitor? This capacitor will discharge, right? From t by 2 to t, the capacitor will discharge. Diode current is 0, but the capacitor will discharge. So I will put this one a bit upward here. Now capacitor is discharging. So what would be the capacitor voltage? It will discharge from 10 to, in this manner it will discharge, right? Now what do you see? For how much time it will discharge? For t by 2 window only, for this much window only. What is the value of t by 2? T by 2 is 1 second. And what is the value of RC? RC is 40. Time constant is very large and time window is very less. That means this value will be very, very less. Say yes or no. And if e to the power minus x, x is very less, then I can replace it with 1 minus x. Basically, it will discharge in this manner. But if it is very low, it was discharging in this manner, but the time window is very low. That means I can linearize it. Say yes or no. So I can approximately linearize it. So what I can write? This I can replace with 1 minus T by RC. This is your VCT. Now what you need to find? Find the potential at a time t. What would be your potential at time t? So that would be tan into 1 minus, what was the window? T by 2 time. So T by 2 RC. So tan into 1 minus, what is the value of T by 2? 1 by, T by 2 is 1, 1 by 40. This is your VCT. This is your VCT. Now your VCT has become, ignore this waveform. Your VCT has become tan into 1 minus, basically tan into tan minus 10 by 40. Tan minus 10 by 40. Okay. Now tell me one thing, at t equals to t plus, what will happen? So let's draw the VC waveform. Let's draw the VC waveform. This is the VC waveform. Initially it was 10 volt. VC waveform I am drawing. Then potential went down. Now at t equals to t plus, what will happen? Here you are having some potential lesser than 10 volt. Across the capacitor you are having some potential lesser than 10 volt. That is 10 minus 1 by 4. And here you are having 10. That means diode will turn on. And if diode turns on, then immediately it will be charged to 10 volt. So immediately your capacitor will charge to 10 volt. Immediately it is charged to 10 volt. Here this was the potential, which was 10 minus 1 by 4. This is 10 minus 1 by 4. 9.75 volt. Here you are having 9.75 volt. Now suddenly it is charged to 10 volt. So at t equals to t by 2 plus, suddenly it is charged to 10 volt. Then what will be your capacitor current? Tell me. C into change in voltage. What is the change in voltage? 0.25 delta t. So what is the value of C? C is 2. C is 2. So 0.5 delta t. This would be the capacitor current here. Here this would be the capacitor current. And what would be the resistor current? Resistor current. Because across the resistor you are having approximately around 10 volt only. Across the resistor. Here across the resistor you are having 10 volt only. 10 volt. So the resistor current would be 10 by R. Now the diode is turning on. Here the diode is turning on. Diode is on. Here diode is on. Here diode was off. So I was not caring about the resistor current or the capacitor current. Why I was not caring about the resistor and capacitor current? Because I need to find the current through the diode. Now in this condition, the capacitor is driving 0.5 delta T current and resistor is driving 10 by R current. Okay. So how will the waveform go? So initially, if I was drawing diode current, this was my diode current. So this was my 10 C delta T and this was 10 by R. Now at T by 2 plus, what is the impulse I am having? 0.5 delta T. And what is the resistor current I am having? 3T by 2. And what is the resistor current I am having? That is 10 by R. Then from 3T by 2 to T. Then from 3T by 2 to 2T. 3T by 2 to 2T. Again what will happen? This capacitor is at 10 volt. Then again input will be at 0. Then again capacitor will discharge. Diode will be off. Here again diode will be off. Again it will turn on. Again it will develop the voltage. The same voltage it will develop. The same cycle will keep on going. Right? So this waveform will keep on repeating. From 3T by 2 to 2T, here diode is off. 3T by 2 to 2T, diode is off. In this time, diode is off. And if diode is off, it will drive 0 ampere current. After that, what will happen? Again, it will drive some current. 0.5 delta T. Because it will discharge in the same manner. Again, it will develop the voltage in the same manner. And resistor will drive the same current, 10 by R. Right? 5T by 2, 10 by R current it will drive. It will keep on going in this manner. Okay? Now you need to find average current. This is the steady state. This is not steady state. This is the steady state. This cycle will keep on repeating. So this is the steady state. Now you need to find the average current. So how will you take the average? What is the average of impulse? What is area divided by time period? What is the average? Area divided by time period. Tell me what is the time period? Time period is this window. Time period is t. Now you need to find the area. So what is the area of 0.5 delta t? That is 0.5 only. What is the area of this much? That is 10 by r into t by 2. Even how to take the average, that also I have taught in that particular video. So if you don't know how to take the average, then it is fine, you can check out there. So 0.5 plus 10 by r. What is the value of r? R value is 20. So 1 by 2 and value of t is 2. So r value is 20. So this would be 1 by 2 only, 0.5 divided by t. T value is 2. So 1 by 2, that means this is 0.5. So this is the average current, that is 0.5 ampere. So this is the answer, which is 0.5 ampere. So this was a very good question. These kind of questions can be asked in the interview. So basically 10 volt came, 10 volt across the capacitor, then 10 C delta T and 10 by R is the resistor current. Then diode went off. If diode is turning off, that means the capacitor is discharging. Capacitor is discharging approximately linearly only. So it is discharging linearly only 9.75 till that it reaches. Then diode again turns on, suddenly capacitor is getting 0.25 voltage, 0.25 more voltage it is getting. So what will be the current? 0.25 into C into delta T. So 0.5 delta T would be the current. Then resistor current would be 10 by R. So this cycle will keep on repeating, and if keeps on repeating, then we can find out the average current. What would be the average current? Area divided by the time period. So area 0.5 plus this area is also 0.5 divided by time period is 2. So answer is 0.5 ampere. So this was a very good question. I hope you enjoyed it. Okay then. Let's see the solution of this one. What you need to find the value of R such that your PMOS transistor will be biased in linear region. So for linear region, what should be the condition? That your VSD should be less than VSG minus VT. Because this is a PMOS, that's why we will write VSD should be less than VSG minus VT. VSD 4 minus, what is the drain voltage? Drain voltage is 1 milliampere into R. So I am considering R to be in kilo ohm. R to be in kilo ohm. If I am considering R to be in kilo ohm, I can simply write R there. Because 1 milli into kilo. So simply I am writing R. Should be less than VSG. VSG, that is 4 minus VT, that is 1. VT is 1. So R should be greater than 1, and R is in kilo ohm, that means R should be greater than 1000 ohm. So R should be greater than 1000 ohm. Only one option is there, which is this one. Okay. So in this particular problem, a lot of data is given. What you need to find? You need to find the value of R2. This current you already know, that is 0.5 milliampere. So this current also you know. You need to find the value of R2. So what I know is that I0 by 10 into R2 is VGS. So my target should be to find the VGS. If I know the VGS, then finding value of R2 will be a cakewalk. So I need to find VGS. How can I find VGS? I know the current, that is 0.5 milli. That would be equals to mu n Cux, that is 0.2 milli, into W by L, that is 278 by 2, into VGS that I need to find, minus VT. VT is 0.4. That's it. So it would be 0.5 by 278. Calculator कहाँ गया? 0.5 by 278. 278 reciprocal plus 0.4. Okay, not 0.5. This will be 5 only. 5 by 278. Sorry. 5 by 278. 5 by 278. 0.15. 5 by 278. 5 by 278 under root plus 0.4. So 0.53. We are getting VGS is equals to 0.53 volt. I hope I did the calculation correctly. 5 by 278. 5 by 278 under root plus 0.4. Yeah, so 0.53 volt. This is the VGS we are getting, which is equals to 0.5 milli divided by 10 into R. This is equals to 0.53. So into 10 divided by 0.5. 0.53 into 10 divided by 5. So 10.68 kilo. So R value you are getting is 10.68 kilo ohm. So this is what we are getting. So this is the answer. Okay, very easy problem. So let's see the solution of this one. You need to find the value of I. So how can you find the value of I? Basically, you have the Kn relation, you know the Kn values and Kn is mu n CX W by L, you know the Vt value. You can find out this potential. If you know this potential, this will also be X, then you can find out the current very easily. So I know Kn1, that is 400 micro. Better I should write here. Basically 400 micro mu n CX W by 2L. Kn1 it is Vsg, that is 0 minus X minus Vt whole square should be equals to 200 micro Vsg, that is X plus 5 minus Vt whole square. Okay, from here you need to find the value of X. So that would be a bit complex calculation, but we have to do it, no other way. So X square plus 1 plus 2X, and here X square, X plus 4 it would be, right? X square plus 16 plus 8X. So 2X square minus X square would be X square, plus 2 minus 16 would be minus 14, and better minus 14 we will write later on. 4X minus 8X, that would be minus 4X. 2 minus 16 minus 14 should be equals to 0. So X value minus B plus minus root B square minus 4AC upon 2A. But value should be negative, X value should be negative. Why it should be negative? Because if it is positive, then the transistor will not even turn on. This is 0. If this is positive, then VGS would be negative. Then transistor will not even turn on. So it has to be negative. So 56 plus 16, then 56 plus 16, then take under root minus 4 divide by 2. So minus 2.24. That would be the potential of this point. Okay, minus 2.24. Now what you need to find? You need to find the current. So if you solve these kind of problems with good amount of patience, then you will be able to solve it very quickly. So in this equation I can put 400 micro 2.24 minus 1 whole square, that's it. This is the answer. So minus 1 whole square into 4, so 6.18. So 6.1 then 0.62 milliampere. After solving it, this is what you will get, 0.62 milliampere. Well and good, 0.62 milliampere. Let's see the solution of this one. What you need to find? You need to find the value of base current. So here, what is the collector current? That you can see, emitter current is 1 milliampere. So what would be the base current? Base current would be 1 milliampere divided by beta plus 1. Beta value is 100. So this is 10 to the power minus 3, 10 to the power minus 2, 10 microampere. Approximately it would be equal to 10 microampere. So this is correct, but this is only correct if this transistor is working in active region. So you have to check that. If this is 1 milliampere, this will also be approximately 1 milliampere only. So 5 minus 1, this would be 4 volt. This node will be 4 volt. This is small signal voltage. So DC bias it would be 0 only. So this is 0 volt. This is 4 volt. And if nothing is given, we will consider 0.7 here. So this would be minus 0.7 volt. So what about this bias? What about this junction? This is reverse biased because this is NPN transistor, NPN. So this is reverse bias and this is forward bias, right? That means it is working in active region. So if it is working in active region, then this formula is correct. So answer would be 10 microampere. If let's just say in place of 1 kilo ohm, if there was 10 kilo ohm, then what would be the answer? Then it would be working in saturation region. Then you would say we cannot determine the base current, okay? Because 10 kilo ohm is there. If 10 kilo ohm is there, then they have to give this potential. Then they have to give the potential across the 1 milliampere source as well. Okay, this would be minus 0.7. Then they can give this potential. If they can give this potential, then you can find out the collector current, not the base current. So basically, you will say we cannot determine the current if the resistance was 10 kilo ohm, but it is 1 kilo ohm only, so it is working in active region. So this is the correct answer. Okay. Let's see this question. Now this will also involve calculation, but you will think that, sir, why you are making problems where we need to solve, where we need to do a lot of calculation, but this will happen in the examination. There will be a lot of problems which involves calculation, so you have to solve it. So IE is 1 milliampere, this is 1 milliampere, okay, IE is 1 milliampere, beta is 99, so what this current would be, because beta is 99, so base current would be 1 milli divided by 100, so that would be 0.01 milliampere, right? This current would be 0.01 milliampere, which I am remembering as of now. This current is 0.01 milliampere. Now this volt will be 1 volt, right? Because 1 kilo ohm into 1 milliampere, this will be 1 volt, and VB is 0.7. VB is 0.7, so this would be 1.7 volt. And if this is 1.7 divided by 17, so that would be 0.1 milliampere. So 1.7 divided by 17, 1 by 10, 0.1 milliampere, and this is 0.01. So what this would be? 0.11 milliampere. So this drop is 0.11 milliampere. Here there is 1 milliampere, so collector current will be approximately 1 milliampere only, right? If emitter current is 1 milliampere, collector current will also be approximately 1 milliampere. So 1 milliampere here and 0.11 milliampere here. So this would be 1.11 milliampere. Very easy problem. What you need to find? V0. So V0 will approximately be 15 minus 1.11 into 1 kilo ohm. So it would be 13.89. So 13.9. Approximately V0 will be 13.9 volt. That's it. So in the examination you can directly see the current. This is one. You current. And what would be the V0? Okay. Very easily you will be able to. Now this is the example of clamper circuit. So from here to here you are going. That means you are clamping up by 25 volt, because this is minus 20, this is 10. So 25 volt by you are clamping up. 10 plus 25 is 35, minus 10 plus 25 is 5. So basically your V0 is V in plus 25. So you need to clamp up by 25 volt. Now how do you analyze a clamper circuit? Basically this is the diode. When it will turn on? It will turn on at negative bias, because this side, N side is connected to V in. So V in should be negative. So what is the minimum value of negative potential? Like least minimum it can go, that is minus 20. If it goes minus 20, this diode will turn on. Then if it turns on, it will be minus 5 here. So what will be the voltage drop? Voltage drop will be plus 15 in this direction, right? Voltage drop will be minus 10, minus 5 and minus 20. That means 15 volt will be in this direction. So what will be your V0? V0 will be V in plus 15, right? What about this one? This diode will also turn on at negative bias. That means this will turn on at V in is equals to minus 20. This will turn on. So here minus 20 will come, and here 5 will come. So what would be this potential? That would be 25 volt. So V in plus 25 volt. V0 will be V in plus. This is how we analyze the clamper circuit. You might not be able to understand it if you are studying it for the first time. You should have the good idea of clamper circuit. How do we analyze it? So basically our target is to turn on the diode, and we will turn on at the maximum supply. If it is turning at the negative, that means maximum negative, minus 20. If it is turned on, here minus 20, here 5. That means 25 it is getting. So V in plus 25. This is what we were looking at. So this is the answer. Okay. Now this is a very simple question on our equivalent resistance. So first we need to find the equivalent resistance between 1 and 2. So talking about 4 and 3. 4 and 3 wires are equipotential. Do you know what do you mean by equipotential? You should know it. What do you mean by equipotential? That I am going from 4 to 1. Then I need to go with the resistance R. And if I go from 3 to 1, then I go with the resistance R only. So it is equipotential with respect to node 1. But with respect to node 2, if it is equipotential, that also we need to check. So from 4 to 2, if you are going, you only see one resistance, that is R. And if you go from 3 to 2, also you see only one resistance, that is R. So that means 4 and 3 are equipotential. 4 and 3 are equipotential with respect to 1 and 2. 1 and 2. That means 4 and 3 can be shorted. So I can write 4 and 3 together. And this is my 1 and this is my 2. So between 1 and 2 there is a resistance R. Between 1 and 4 there is a resistance R. Between 1 and 3 there is a resistance R. So R and R will come in parallel. This would be R by 2. Between 2 and 3 there is a resistance R, between 2 and 4 there is a resistance R. So again R and R will come in parallel. So this would be R by 2. Between 1 and 2 you need to find. Between 1 and 2 you need to find. So R by 2 will come in series. So this will become R and R parallel will be R by 2. So what would be the equivalent resistance? That would be R by 2. R and R will come in series. This will be in series. R by 2 will be in series. R parallel R will be R by 2. Same goes for other one. That is 1, 1, 3. 2 and 4 will be equipotential. So R by 2 will be R and R parallel will be R by 2. So the next one you can solve on your own. That would be R by 2 only. Okay. Now this is a very easy program. 3 ampere is here, 4 ampere is going here. That means 1 ampere would be coming from this side. This is 1 ampere, this is 1 ampere. That means 2 ampere would be coming from this side. So Ix is minus 2 ampere. That's it. Or what you can see, 3 ampere is coming out of the ground, 3 ampere is going into the ground. 4 here, 1 here. That means 2 would be going here. So what do you see? 3 ampere is coming out of the ground, 3 ampere is going into the ground. 2 ampere is going into the ground. That means 2 ampere would be coming out of the ground. So Ix 2 ampere should be coming out of the ground. So Ix should be minus 2 ampere. Are you getting this point? 3, 4 and here 1. This is 1, so this would be 2. So Ix is 2 ampere, minus 2 ampere. In that manner you can see, or you can see whatever the current ground gives, the same current it will take. For whatever the current it takes, it will give the same current. So 3 ampere is going out, 3 ampere is going in. 2 ampere is going in, 2 ampere should come out. So 2 ampere should come out. Okay. Let's see the solution of this one. Energy supplied you need to see. So a lot of questions will be there on energy supplied. So whenever they ask you energy supplied, this is the first thing you will do. No formula you will apply. This is just the first statement you will write. Energy is equals to minus infinity to infinity power into dt. And what is power? Power is voltage into current into dt. That's it. Now what they are asking, energy supplied by the source. So you know the current from the source. You just need to find the voltage. You just need to find this voltage Vt, and this voltage will be equals to this voltage, right? So Vt is equals to Vct, and that would be equals to 1 by C integration I dot dt, right? And that would be equals to 1 by C integration, what is I? That is 5 delta t into dt. So tell me one thing, what will be the integration of delta t? Minus infinity to infinity, 1. So what would be the voltage? 5 by C volt. Voltage will be 5 by C volt. So minus infinity to infinity, voltage is 5 by C. What is the current? That is 5 delta t into dt, right? So 25 by C, minus infinity to infinity, 25 by C, and C is 1 farad, right? C is 1 farad, 1 into delta t dt. What is the integration of this one? That would be 25 only. So answer is 25 joule, because integration 25 is constant, that will come out, and integration of delta t is 1 only. So answer would be 25 joule. Are you getting this point? Okay, so never apply any formula. If you apply half CV square, this will be wrong. Always you need to write down voltage and current and then simply integrate. That's it. Okay, with the time window. So time window is from minus infinity to infinity. So 25 joule we are getting. Otherwise you would have got 25 by 2 joule. That is wrong. Okay. Let's see the solution of this one. What you need to find? You need to find V naught at t equals to 1 second. V naught at t equals to 1 second. So what kind of circuit is that? With respect to voltage, it is first order circuit. Why it is first order circuit? Because across the inductor, if I give V1 voltage, so across 1 Henry, I can write down the potential, that is 4 minus V1. So only one variable is there, one state variable is there. So it is first order circuit with respect to V naught. At t equals to 0, what will happen? V naught value at t equals to 0. Both inductor will be open circuited. So simply 4 volt will come across it. So 4 volt. At t equals to infinity, what will happen? At t equals to infinity, both inductor will be shorted, right? Both inductors will be shorted. At t equals to infinity, what will be the frequency content? Omega equals to 0. I hope you know all these concepts. So at t equals to infinity, frequency content will be omega equals to 0. If frequency content is omega equals to 0, then how this will be replaced? Omega equals to 0, that means very less impedance, and this is some finite impedance. So parallel combination of RL can be replaced with the simple L only, right? And this is replaced with 3 Henry. And this is your 4 volt. Volt, 1 Henry and 3 Henry. and this is your V naught t, V naught infinity. So what will be your V naught infinity? That would simply be 3 by 4 into 4. That would be 3 volt. So V naught infinity is 3 volt. What would be the time constant? Time constant would be L equivalent by R. So what would be L equivalent? That would be 3 by 4. And R is 1 only. So this would be your time constant. So what would be your V naught t? From 4 to 3 it is going. So 3 plus e to the power minus t by tau. Tau is 0.75. At what time they are asking? At 1 second they are asking. So at 1 second, what it would be? 0.75 reciprocal plus minus e to the power plus 3, 3.26. So very easy. But for current it is second order circuit, okay? For current it is second order circuit. In the course I have explained, like the order of the circuit doesn't depend on the circuit. It depends on the input and output. So if I say V naught S by V in S, then it is first order. But if I say I naught S by I in S, so I naught S by V in S, then it is second order. And if I say I naught S by I in S, let's just say this is my I in S, this is my I in T. So if I say I naught S by I in S, then what would be the order? Zero order. Why is that so? In the next solution only we will see this thing. It would be zero order, because the same current will be flowing here. So I naught S will be equals to I in S only. So transfer function will be 1. So it will be zero order. So in the same circuit, with respect to output and input, order can be different. Here it is first order. With respect to current, it will be second order. And with respect to current, it would be zero order. Okay, so I hope you know these kind of concepts. Okay, then let's see that. So in this question, the switch is opened at t equals to 0. That means 5 ampere is exposed. Basically, this 5 ampere will be 5 ut now. Because the switch was closed, then 5 ampere was flowing from here. Now it is open, so 5 ampere is exposed to the circuit. So 5 is acting as 5 ut now. Now you need to draw the Vs waveform. So what will be your Vs waveform equal to? V naught t plus V1 t. Say yes or no. Your Vst is equals to V naught t plus V1 t. Now tell me one thing, this 5 ampere current is there. This 5 ampere current will flow from here and then will flow here, right? 5 ampere will flow from 3 and 1 ohm and then will flow here. This 5 ampere current. Now across this 2 Henry inductor, this is the same as the previous RC circuit. Do you remember in AIMT 1 I asked this same kind of RC circuit. There R and C was there, then there was a C. Here what is the change? The change is C is replaced with L, that's it. So in 2 Henry inductor there will always be 5 ampere current. Say yes or no. Always there will be 5 ampere current, right? No one can change it, because 5 ampere will flow here, it will be divided into these two, then 5 ampere will come. So always there will be 5 ampere current. So what would be your V naught t? V naught t would be L dit by dt, and this current is constant now. So what that would be? 2 into differentiation of 5 ut, that would be 5 delta t. So V naught would be 10 delta t. V naught t would be 10 delta t. And if I draw the V naught t waveform, how it would look like? This is how it would look like. Impulse of 10. This is the flux, volt into second. The unit is volt into second. So this is the flux, V naught t. This kind of in-depth analysis we have given in the course, right? So if you have studied it there, then it is good. Otherwise, like I hope you are understanding here at least. So what I wanted to deliver, I hope you are understanding the concept. So this is V naught t. Now I need to talk about V1 t. So talking about this parallel RL, what will happen initially? Initially inductor will drive 0 ampere current, right? Inductor will take 0 ampere current. So the whole current will be flowing through this 1 ohm resistance. Whole current will be flowing through this 1 ohm resistance. So what will be your V1 at t equals to 0 plus? Whole 5 ampere current is flowing through this 1 ohm, that will be 5 volt. At steady state what will happen? At steady state inductor will be short circuited. Say yes or no. Inductor will be shorted. At steady state inductor will be shorted. So all the current will be flowing through this 3 Henry inductor. No current will be flowing through this resistance. So what will be the voltage drop? 0 volt. Because inductor is shorted, so V1 will be 0 volt only. So from 5 to 0 you are going with the time constant of what? In the calculation of time constant, this 2 Henry will not even come in action. Why it will not even come in action? because this 5 ampere is divided between R and L. Not, there is no use of this. What this 2 Henry is doing? This is giving an impulse voltage, that's it. Then it is gone. It gave the impulse voltage, now it is gone. So what will be your time constant? That would be L by R, 3 seconds. That's it. L by R. L by R. Time constant will be 3 seconds. Are you getting this point? Did you understand this? Or how you can see? For calculating the time constant, what do? You open circuit this, right? You open circuit the 5 ampere current source. You open circuit this. If you open circuit this, then what will be the equivalent inductance? This 2 Henry will not come in parallel, right? Because this is open circuited. So there will be no use of 2 Henry because there is no current through this 2 Henry. You have to find the equivalent inductance here. So that will be 3 Henry only. And what is the equivalent resistance? That is 1 ohm. So 3 by 1, 3 seconds. Or with the concept, you need to see 5 ampere is going between these two, and then 5 ampere is completely flowing there. So this is just giving you an impulse, nothing else. So RL circuit is this, which is giving you 3 seconds. And V1 initially is 5 volt, and at steady state it is 0 volt. So from 5 to 0 it is going. Also, how you can understand it, other ways are also there. So I will just give the intuition. What you can say, basically this is your V1T. So initially the complete current is flowing through this resistance. That means it will develop some voltage. What voltage it will develop? 5 volt. Then 5 volt is developed here. If 5 volt is developed here, that means inductor will drive some current. So if inductor starts driving some current, that means the current here will be lesser. If current here is lesser, that means the voltage drop across the resistance will be less. And the same voltage drop is there across the inductor as well. So that will also be less. So slowly the voltage drop across the inductor is decreasing. So slowly the voltage drop will go to 0. So at that time voltage drop will go to 0, and at that time it will drive the complete current, that is 5 ampere. This is the complete intuition, not the intuition, this is the complete concept that how the current is flowing. Otherwise you can check at t equals to 0 as well, t equals to infinity as well. So this will be the exponential response. So from 5 to 0 it will go with time constant of 3 seconds, and here there will be an impulse. So this is the answer. So this was a very good question. I hope you have understood that every single concept behind it. Okay then, thank you. Let's see this question. This question is based on the steady state analysis of sinusoid steady state analysis of RC circuit. Sinusoid steady state analysis of RC circuit. Here the input is not DC. Input is sinusoid, 5 sin t. Your input is 5 sin t. So there is a fixed way of solving these problems. First you need find the steady state voltage. First you find the steady state voltage. Then you get to know that there will be some transient part as well. Then you add up that transient part. So first you find the transfer function. What will be the transfer function? Here what is the omega? Omega value is 1. So first you find the transfer function. I hope you know the concept. Otherwise you will not be able to understand it. Okay, there is a certain concept of solving it. The topic name is AC transient. Okay, so 1 upon SRC plus 1, 1 upon S plus 1, and if you write it in terms of omega, that would be 1 upon j omega plus 1, and omega value given is 1 only. So you can put that equals to 1. So what would be the magnitude? Magnitude you are coming out to be 1 by root 2. And what is the angle? Angle is coming out to be minus 45 degree. So what would be your V naught T? That would be 5 into the magnitude, that is root 2 sine T plus the angle. Angle is minus 45. But this is not the complete answer. This is only the steady state. If I put T equals to 0 here, if I put T equals to 0 here, if I put T equals to 0 here, what I am getting? If you put T equals to 0 here, 5 by root 2 into 5 by root 2 into 1 by root 2. So that would be minus 2.5 volt. So if I put T equals to 0 here, I am getting minus 2.5 volt. But actually the value should be 0 volt. At T equals to 0, the capacitor should have 0 volt, right? But in this expression you are getting minus 2.5 volt. That means you are missing the transient part. What the transient part will be? So what will be the complete expression of V naught T? This is the steady state part, 5 by root 2 sine T minus 45, and then there will be a transient part as well. What that would be? Plus 2.5 e to the power minus T by 2. Tau is RC. If you put T equals to 0 here, you will get 0 volt. V naught at T equals to 0. That would be minus 2.5. Put T equals to 0 here, plus 2.5 would be equals to 0 volt. Okay, so here you will get 0 volt. So first I will find the steady state voltage. Then I get to know that this is not correct. There will be transient part as well. So that transient part I have to include. So how will I include? I am getting minus 2.5. That means there has to be plus 2.5 which will make it 0. And slowly this transient part will die down. So this transient part will die down, and at steady state you will just have the sinusoid. So this is the waveform, and then these two added up, these two will add up, and at the steady state you will have this waveform only. Okay. So this is the final expression, and RC value is 1, so I can put 1 here. Now what they are asking? V0 value at 1 second they are asking. V0 value at 1 second. V0 value at 1 second. So 5 by root 2 sine time t is 1, which is in radian. So here I have to put pi by 4 plus 2.5 e to the power minus 1. So if you solve it, you will get 1.67. Okay, 1.67 volt. This will be your V0. Okay, so not very easy, but if you know the concept, you will be able to solve it. If you don't know, then you will not be able to solve it. So these kind of questions can come in your interview. They can ask you to write down the V0 t expression. Then you will write down this only. Then they will confuse you. Then you will say that there will be a transient response as well. Okay. Let's see the solution of this problem. This is also a good problem, and these kind of questions will come in your interview. So if they are asking the slope, no, this is a slope only, dv by dt. This is a slope only. So in case of capacitor, they will ask the slope of voltage. In case of inductor, they will ask the slope of current. Why is that so? Because for capacitor current, we know the equation, that is C dvc by dt, right? So if you know the current, you can tell the slope without even writing the expression of VCT. And in case of inductor voltage, we know VL dit by dt. So if you know the voltage across the inductor, then you can write down the slope as well. So that's the thing. Okay, so what is our target? Our target is to find the capacitor current. But what is the scene here? This is there for t less than 0, and this would be there for t greater than 0. So first we will analyze the circuit for t less than 0. So first we will reach at steady state at t equals to minus 0. First our target is to get at t equals to minus 0. So let's get at that condition. So what will happen at that condition? T equals to minus 0. So at t equals to minus 0, this is not there. Capacitor will be open circuited and this will be shorted. Inductor will be shorted. So what would be the current? I at 0 minus. That would be 4 by 8. 0.5 ampere. What would be your V of 0 minus then? That would be 0.5 into 5. That would be 2.5 volt. So this is having 2.5 volt here. This would be your 2.5 volt. And this current is 0.5 ampere. Now at t equals to 0 plus, what will happen? At t equals to 0 plus, you need to check. At t equals to 0 plus. Okay. If this is 2.5, this is 5. 2.5 by 5. That means this is 0.5 ampere. And this is 4. So this would be 3.5 ampere. From here 3.5 ampere current coming, from here 0.5 ampere current coming. So this would be 4 ampere. So basically you go to know your IC 0 plus. IC 0 plus is equals to 4 ampere. That is equals to C dvc by dt. C dvc by dt. And C is 1 farad only. So dc by dt. dc by dt. dv by dt. dv 0 plus by dt. It's been 4 to 5 hours I am continuously recording, and those 2 hours messed up. Okay, so that's why I'm a bit tired. So P is 4 volt per second. Now Q is interesting. For that you need to find the voltage across the inductor at t equals to 0 plus. So at t equals to 0 plus, this is gone now. This is gone. At t equals to 0 plus, this is gone. Inductor will drive the same current. Inductor will drive the same current. So it will drive 0.5 ampere current only. So what would be the voltage drop here in this direction? 1.5 volt. Now tell me one thing. This is your inductor. Okay. And current is flowing in this direction. Because I need to find di by dt. I need to find di by dt. And I current is flowing in this direction. Then where I will calculate the voltage drop? This, no. So I can write V is equals to L di by dt. Say yes or no. Is that correct? Vt is equals to L di by dt. If current is flowing in this direction, then voltage drop will be from plus to minus. Vt is equals to L di by dt. So my target will be, this is my current. So my target is to find the voltage here and here. So here voltage is minus 1.5 volt. This voltage is, because this is 0. So 0 minus 1.5. This is minus 1.5 volt. And what is the potential here? That is 2.5 volt. And in which direction I need to write the potential? From left to right. That means in this direction I need to write down the potential. So this is minus 1.5, this is 2.5. So this would be minus 4 volt. So this potential is minus 4 volt. So what did you understand here? What is the final conclusion? Basically you are having minus 4 volt in this direction. This is your 0.25 Henry. Okay, and the current that is flowing is 0.5 ampere. Well and good. So VL, that is minus 4, is equals to L. L is 1 by 4 is equals to di0 plus by dt. So Q value is coming out to be minus 16. So Q is minus 16 and P is 4, minus 16 ampere per second. So 4 into minus 16, that would be minus 12. So this is the correct answer. Okay, 4 minus 16 minus 12. Well and good. Okay, this was a good question. You need to see the direction as well, in which direction voltage is there. Okay, so take your time. In these kind of questions you should take the time, then you should give the final answer. Let's see the solution of this one. You need to find the total charge till 9.5 second only, not till 10 second, 9.5 second only. So what will be the charge? Charge is integration I dot dt. So you just need to find the area. So 5 into 2 minus 10 plus this area is minus 10. What about this? This area is minus 1. This area is minus 1. 1 by 2, this area is minus 1. What about this one? 1 by 2 into 1.5 into 4. 1 by 2 into 1.5 into 4. 3. So this area is 3. And what about this one? 4 into 2, this area is 8. So total charge is 0. This was very straightforward. I hope everyone was able to solve it. So this was very easy problem. Okay. So this is the end of our technical, all the technical problems. Let's go to the aptitude part now. So what they are saying, A is thrice as good as workman as B, therefore is able to finish the time in 60 less days. Okay. So work is W. Okay. If the efficiency of B is X and it takes time T, so the same work efficiency of A is 3x and it will take time T minus 60 days, right? T minus 60 days. Well and good. Now what they are saying, if both are working together, the same work is there, both are working together, that means efficiency is 4x now, then how much time it will take? So days you need to find. So what I can do from here, I can find the W in terms of X only. So for that I need to find the value of T. So X into T is equals to 3x into T minus 60. So if I solve it, what I will get? T is equals to 90, right? Not 90. T is equals to 90 you are getting. Solve kar hi lo na yaar. 3t, T is equals to 3t minus 180. Yeah, T is equals to 90 you get. Because 90, 30. Yeah, T is equals to 90. So we are getting T is equals to 90. So what is work? Work is 90x. That is equals to 4x into days. So days is equals to 90 by 4. That is 22.5. So days is 22.5. Very easy problem. Okay. Let's see the solution of this one. A large cube is formed from the material obtained by melting 3 smaller cubes. What will be the ratio of total surface area of the smaller cube to the larger cube? So if large cube is framed from the smaller cube, that means I will equate the volumes. So what is the volume of small 3 cube? That would be 27. 4 cube would be 64 plus 125. That would be equals to the volume of the larger cube is equals to A cube. So from here I will get the side that is 6 centimeter, which I remember already. Okay. Now what is the ratio of the total surface area of the smaller cubes to the larger cube? So surface area, total surface area, that is 6a square. So 6 into a square, 3 square 9, 4 square 16 plus 5 square 25 divided by 6a square, that is 36. So that would be 50 by 36, or you can say 25 ratio 18. Okay, very easy problem, very straightforward. Now this problem is based on data interpretation. So in the last AIMT as well, I told you one thing: whenever you solve the problems of data interpretation, always read the paragraph very carefully, read it very slowly. Otherwise you will have to read it again, you will waste your time. So you may take 2 minutes, 3 minutes or even 4 minutes, but read it slowly. Okay. So what they are saying, the total of the first 3 deficit country is this much crore. Deficit, they are in deficit. they are in deficit, they are in deficit, and they are in surplus. So they are talking about deficit only. 5 deficit country, then the last 5 deficit country, and then this is the data given. Now what they are asking, read it very carefully. The average of the total deficit of the middle 5 deficit. So you need to take middle 5, but not of the whole. You need to take the middle 5 of the deficit only. Okay, the average of the total deficit of the middle 5 deficit only. That means you need to take the deficit, middle 5 of the deficit. So how many deficit are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. 13 deficit are there. So you have to take the middle of middle 5 of that. So 13 minus 5 is 8, right? So 8 by 2, 4. So 4 you need to drop here, and 4 you need to drop here. 1, 2, 3, 4. 4 you need to drop here till Australia. Okay, now you need to take the average of these 5. So this is what you need to do. So average of these 5, what that would be? 514.1 plus 505.3 plus 425.7 plus 366.6 plus 134.9 divided by 5, and that will come nearly around Korea. Okay, that will come nearly around Korea. So always read it carefully. They are not talking about the whole countries, they are only talking about the deficit one. So middle 5 of the deficit one you need to take. Let's see the solution of this one. So a train is traveling 50% faster than a car. Both start from a point A and reach the point B at same time, which is 75 kilometers away. So this is A, this is B. Both start at the same time, 75 kilometer away. Both reaches at the same time as well. This is x, this would be 1.5x. Train is running with 1.5x, and both are reaching at the same time. Why they are reaching at the same time? Because they say that the train lost about 12.5 minutes while stopping at the station. So train lost 12.5 minutes while stopping at the station. That means if you are running with the speed of x kilometer per hour, that means you are taking time t. But if you are running with the speed of 1.5x, you are taking time t minus 12.5 by 60, right? Say yes or no? You are taking lesser time. Why you are taking lesser time? Because you are stopping for 12.5 minutes, no? So if you had worked for 1.5x without stopping, then you would take this much time only. Now what you need to find? You need to find the value of x. So if I subtract both of the equation, what I will get? I will get 12.5 by 60. So this will be 3 by 2, 50, 25 by x. 25 by x, x would be 120. X would be 120 kmph. Okay. So this is answer 3. So this was easy, this should have been solved. Let's see the solution of this one. What you need to find? Ratio of the perimeter of the outer circle to the polygon ABCD. Ratio of perimeter of polygon to the outer circle. What is the radius of the outer circle? This is the radius of the outer circle. This is the radius of the outer circle. Okay, OS. So first let's find OS. Now tell me one thing. From the outer point, if I draw two tangent, both will be equal, right? If this distance is x, this will also be x. Now what this distance would be? This would also be x only, right? Because both are parallel, this would also be x. So what would be your OS? That would be root 2x, right? So OS is root 2x. Now AP is x as well, right? Because this is a square. So if this is x, this is also x, and this is also x. So what would be your AB? AB. This angle is 90 degree. This is x, this is x. What would be your AB? AB will also be root 2x. Understood? This is x, root 2x, and this is x, AB will also be root 2x. So what would be the, what they are asking? Ratio of the perimeter of the outer circle. That would be 2 into pi into r divided by 4 into AB. So this and this is getting cancelled. Answer is pi by 2. Well and good, very easy. Okay, very straightforward. In this problem, you need to find the water image. So there could be two questions. They can ask mirror image. That means you need to find image here. And if they are asking water image, that means you need to find the image here. Water image. Here you are standing, water image. Okay. So basically these two balls will come here. So this option is gone. Now the empty part will be upper side, the filled part will be downward side. Filled part will be upward side and empty part will be downward side. So all are same only. And why this is colored? This is also one. Now these two are same as well. Now we need to talk about this box. So this is the box. This is the box, and this upper part is colored here. Okay. And water image we need to make. Now in water image, this point will be here, right? This point will be here. This point, this middle point, this point will be here, and this point will be here, right? This is my water. This point will be here. This point will be here. So basically, upper point will be at the more distance. So the line will come something like this. If you don't understand anything directly, always take up the points. This is how I do. If I don't understand anything, I take the points. So this point will be here, this point will be here. I can draw the line now. Now this dark circle will be this dark this side, right? So this is how it will look like. So what is the option? Fourth, because here it is different. So fourth is the answer. Okay, well and good. So here in this problem you should have a good idea of HCF and LCM, then only you will be able to solve it. So HCF of two numbers are given. That means what would be the two numbers? 23x and 23y, with the condition that x and y are co-primes. If x and y are co-primes, that means they are not cancelled by any other number. What do you mean by HCF? The largest number which will divide both of the numbers. The largest number which will divide both of the numbers. So 23 will divide both of them, right? And the two factors of LCM are 13 and 14. Then what would be the number? What do you think? 23 into 13 and 23 into 14. Why is that so? What will be the HCF of this? The largest number which will divide both of them, 23. What would be the LCM? LCM will be 23 into 13 into 14. So other two factors are 13 and 14 only. So these are the numbers. The larger number is this 23 into 14, which is 322, I guess, as far as I remember. 23 into 14. 322. What they are asking? The sum of the digits. 3 plus 2 plus 3 plus 2 5, 5 plus 2 7. So answer is 7. Sum of the digits they are asking. Answer is 7. Let's see this one. You have to make a committee. So there are 7 men and 6 women. 5 persons are to be selected to frame a committee of at least 3 men should be there. Okay, at least 3 men should be there. So 7C3 I can do, and then 6C2. 5 people should be there. Then 7C4 I can do, 6C1, and then 7C5 I can do, and 6C0. So what would be your 7C3? 7 into 6 into 5 divided by 6, 35. What would be 6C2? That would be 15. Plus 7C4 would be equal to 7C3 only, that would be 35. And that would be 6. 7C5 will be equal to 7C2 only, 7C2 would be 7 into 6 divided by 2, 21 into 1. Okay. So 35 into 21 plus 21. 35 into, so 36 into 21 is the answer. 756. 756. So by calculating it, we get 756, which is very easy problem, very easy on PNC. Let's see this one. There are the captain of 11 member team is 26-year-old. Okay, and the wicket keeper is 3 years older. That means wicket keeper is 29-year-old. If the ages of these two are excluded, then the average age of the remaining player is 1 year lesser than the average age of the whole team. So let's just say average age of the whole team is X. That means 26 plus 29 plus the age of remaining 9 player divided by 11 is equals to X. Say yes or no. So that means 26 plus 29 is equals to 11X. Now what they are saying, average age of the remaining player divided by 9 is 1 less, right? So addition of the average age of these player is 9x minus 9. Are you getting this point? Average age of the remaining player is 1 lesser, so x minus 1. So addition of all these ages is 9x minus 9 only. So 26 plus 29 plus 9x minus 9 is equals to 11x. So that would be 56 is equals to 2x. So x is equals to 23. So So x is equals to 23. That's it. Okay. So this is the final answer. Now this is the last question. A vessel is filled with the liquid, 3 parts of which are water and 5 parts of is syrup. So basically, if there are 8 gram total material, then 3 gram is water and 5 gram is syrup. 5 gram is syrup. Okay. Now you are taking off some x amount from here, some x gram you are taking out, and then you are adding up x gram water. So how much should be x? This is what they are asking. What you will do, you will take out x gram and you will add up x gram water such that both will be equal. Water and syrup will be equal. Water and syrup will be 50-50. This is what they are asking. Okay. So I told you one thing. Whenever you take out something from a mixture, if you are taking out something, you will take out in the proportion, right? If I am taking x gram out of this, then I will take 3x by 8 gram of water and 5x by 8 gram of syrup. X gram I was taking out. Water and syrup was in the ratio of 3:5. So water I will take 3 by 8 times and syrup I will take 5 by 8 times. Are you getting this point? Okay. So this much water is left now and this much syrup is left. Then I am adding up x gram water more. I am adding up x gram water more. And now both should be 50-50. That means both should be equal. So basically 3 minus 3x by 8 and then x I am adding up should be equals to 5 minus 5x by 8. Are you getting this point or not? Right? So how will you solve it? 5x by 8 and this would become 10x by 8. 10x by 8 is equals to 2. So x is equals to 1.6. So basically you need to take out 1.6 gram of mixture and then add 1.6 gram water. Basically if you take 1.6 gram of mixture out and add 1.6 gram of water, both will be 50-50. You can check here as well. If I take 1.6 gram out of it, then how much water I will be taking out? 1.6 into 3 by 8. 0.6. So I will be taking out 0.6 water. So I will be taking out 0.6 water. That means I will be left with 2.4. And 1 I will be taking out this one. And 1 gram I will be taking out from syrup because 5 into 0.6 divided by 8. Sorry, 5 into 1.6. 5 into 1.6 divided by 8. That means 1 gram I will be taking out syrup. So I will be left with 4 gram. And then I will add up 1.6 here. So 4 gram is equals to 4 gram. So total 8 gram would be there and 4 gram will be water, 4 gram will be syrup. So 1.6 gram you need to take out, which is how much part of 8? So 1.6 divided by 8, that would be 1 by 5. So answer is 1 by 5. It is 0.2 part or 1 by 5 part. So it is 1/5 of the total mixture. Okay, so that's it. This is the complete solution. And now if you are looking for any for more practice resources, then there are aptitude test series available as well, or there is this test series available as well, which I have already shown, which you can purchase. Okay, so there will be 320 plus high practice problem will be there. So everything that is required for your written test of upcoming companies, so that will be cleared here, and also you will get this detailed video solution as well, which I will be working on. Also you will see where you stand with respect to your competitors. So topic wise tests are there, aptitude is also there. Not the complete aptitude test series there. Aptitude test series is different, which you can purchase. That you can get in somewhat around 100 rupees only if you apply the code India 78. So this code is valid till 15th of August. So that also you can see, and this test series also you can see. Okay. So a lot of good questions will be there and you will have good enough practice. And if you want to purchase these courses, then you can consider buying these courses as well. Here you will get everything: aptitude, technical part, non-technical part, test series, videos, like video content, 180 hours of video content is also there. All kind of interview questions are there. So everything is there in this particular course. Okay then. So yeah, thank you very much. Don't forget to apply the code, that is India 78.